All right, you are all welcome to this channel, and thank you for tuning in. Today, our lesson is on calculus, specifically the graphs of calculus. Looking at this question closely, you'll find that we are given the derivative of the function, which is cubic function, and the straight line h at x that are sketched below. And this is a g prime, which is the derivative of g, which is not shown, and the graph of h at x. Now, having given this information, we need now to apply the knowledge on how we work with a cubic function when you are given its derivative. So we need to now understand the perimeters around the cubic function in its gradient. Now, we are given this h and g, and of course we have e, that they are intersecting right at e, and we have c, coordinates of c, which are the x-intercept of this derivative, and also d is the x-intercept of the very same derivative. Now, we are being told that AB, which is this line, is parallel to y-axis. Well, now, with the first question, it asks us to write down the coordinates of E. We're just gonna write them down. Remember that we do have the equation of this function, which is a 2x minus 4, which means now at E, this E is the y-intercept, where x is equal to 0. Then when we put 0 here, we get just negative 4. So the coordinates of E is just 0 is to negative 4. Moving to the next one. Let me just write negative 4 here. Determine the equation of graph G prime in a form y is equal to ax squared plus bx plus c. Then you will just remember this is just a parabola. And how do you determine the equation of the parabola when you are given this information? Here we are having 2 x-intercept and one other point. 2 x-intercept and one other point. We need to understand how we determine the equation of a parabola function, because this derivative g prime of x is just a parabola. So now we are having y is equal to a into x minus x1, then x minus x2. Then this is how we find the equation when you are given 2 x-intercept and one other point in a graph. Then let's continue substituting. Now we are going to use this negative 4 in the place of y, knowing that in the place of x, this x, we are going to put 0, because this is going to be the corresponding value of x at e. Then therefore we are looking for a by doing that. Then we have 0. Then we have the first one is negative 2. Then we'll be having just positive 2, then squared. Then no, not squared. Then therefore we also have another 0. Then this one is 6. Then we'll be having negative 6. So finding a is to say, okay, we have 2 times negative 6, which is negative 12 a. Then our a is gonna be equal to negative, okay, it's gonna be positive 1 over 3. So this is our a. Now continuing using our function, we have y is equal to now negative 1 over 3. This is 1 over 3 into x plus 2, then x minus 6. Then this is what we have. Then this is equal to, then we have 1 over 3, then we have x squared, then minus 6 x, then plus 2x, then minus 12. Then of course when we simplify, we'll have our y being equal to 1 over 3x squared. Then Then we have negative 4 here. Negative 4 times 1 over 3 is going to be negative x, negative 4 over 3. Then therefore we also have negative 4. Then we are having this one now as our equation of our graph, our hyperbola of our derivative, which is g prime at x is equal to 1 over 3 x squared minus 4 over 3 x minus 4. So this is our equation now. Now moving to the next question, determine or write down the x coordinate of the turning point. The x coordinates of the turning point of g. Remember, g is what you call, g is the equation of the cubic function. Now we're given the derivative now, which is g prime, that now equal to 3x squared, then minus 4 over 3, then x, then minus 4. So this is what we have. Then we are required to write down the coordinates of the turning point of g. The turning points of graph g of the cubic function, how do we read them? The x coordinate, how do we read them in the graph? The coordinates of the turning point are the x coordinates of the x-intercept. These are the x-intercept. The x-intercept, they are also the x coordinate of the turning points of the original function. So the first x coordinate of the turning point is negative 2. Then the second one is x is equal to 6. So these are the x coordinate of the turning point of the cubic function when the gradient or the derivative is given. This one is the x coordinate of the turning point, and this one is also the x coordinate of the turning point. So you just take the x-intercept of the derivative for the x coordinate of the turning point of your original function. Coming to number 2.4, write down the x coordinate of the point of inflection of the graph g. So the point of inflection of the x coordinate of the point of inflection of graph g, we know that we just find the difference, the midpoint of the x coordinates of the turning point, or the midpoint of the turning point. So we have xc, then plus xd, then divided by 2 is going to be equal to the x coordinate of point of inflection. So xc is negative 2, then plus xd is 6, then divided by 2, then you will get 4 over 2, which gives us just 2. Yes, then this is the x coordinate of the point of inflection. This is how we find it. Otherwise, this is the value that we have here, which now the x coordinate of the turning point of your derivative is the x coordinate of the point of inflection. So this x on I upper with turning point, which is 2, also the x coordinate of the point of inflection in your original function. How do we find it? Especially when you have both of your x coordinate of the turning point, just find the median, add them together, then you divide by 2 to find the midpoint of these two points, which is now gonna be just 2. So we are done with number 2.4. Let's come to number 2.5. Number 2.5 says, explain why g has a local maximum at x is equal to negative 2. To this x coordinate, which is negative 2, is the local maximum. How do we then know that this is the x coordinate of the local maximum? We need to remember the function that we are having, that this gradient, this is the gradient, and the gradient, if we can just draw the line here, the gradient before -2 was positive. This is a positive gradient. This gradient is positive. Yes, it's positive because it is above x-axis. And after -2, you can see that the gradient is negative because it is now below x-axis. Now, which means before -2, your graph, your graph was increasing because it has what? A positive gradient, which means now your graph was increasing up until it reaches x is equal to -2. Then after that, you can see that the gradient is now negative. Now that is why our equation, our graph now is going to go down, so that it has what? A negative gradient. So this is our graph now going straight to a, yes, which means our gradient is still negative, our gradient is still negative, our gradient is still negative. Then you can see that now here after 6, you can see that the gradient tends to be positive again, which means your graph has to turn up, then inyuke again. So which means now this is your local minimum, and this one is the local maximum, and then this one is a local minimum. So that is why we judge this -2 to be what? To be a local maximum, because your graph on either side of -2, you can see it started to increase, now it is decreasing, and then started to increase, now it is decreasing. That means once it start to increase then decrease, it's going to have a local maximum. Then here, once it start to decrease then increase, then it's going to have a local minimum. So this is how you can judge it when you don't have the original function. So this equation, we are done with it. We managed to use the derivative to find some perimeters on the original function, that is the cubic function. Now let's come to the second one. The second question, it talk about, okay, here we are given the function itself, which is fine, that f at x is equal to -2x cubed plus ax squared, then bx, then c, is sketched below. The turning points of this graph is t and s, and you can see that these turning points are given to us. Now the first question says, show that a is equal to 21 and b is -60, then c is equal to 43. Then how do you go about doing this? First of all, we will have to use our equation and our points, of course, then to generate some equations to solve. Now what are we having here? We have this function that we can find ourselves using this coordinates of s, which is the turning point, and substituting to f at x, then which means here we're going to put 18, then in the place of x we're going to put 5. So if we can do that, we will obtain 18, because we are looking for a, b, and c, so we will have to use our equation. So that is why we are taking this 18 and substituting in the place of y, and 5 is going to be substituted in the place of x. Now what are we having? We have 18, which is equal to -2x. In the place of x we put 5, then cubed, then plus, then we have a into 5 squared, then plus b times 5, then plus c, then plus c. So we are having this one now, and what we can do now, we're gonna say we are having 18 Then if we can press the calculator, otherwise this is 125 times 2, then we get 250, negative 250 here, then plus 25a, then plus 5b, then plus c. So here we can just have then 18 plus 225, then we're gonna have 268, which is equal to 25a, then plus 5b plus c. So if we can just have this one for now, then we'll remember something, that this at the turning point, we remember one thing, that the derivative of a function is equal to 0. So on that note, we can just say, yes, what I'm thinking of having what? Yes, we are having this one. Then at the end of the day, let's just try to differentiate this function. Then we will be having negative 6x squared, then plus 2a alpha a x, then plus bx. So this is what we have now. Then on that note, we can just say we are having, okay, what I'm thinking of taking this one, I'm thinking of taking this one. We have f at x is equal to negative 2x cubed, then plus a x squared, then plus bx plus c. So let's find the derivative here. Then f prime of x is equal to negative 6x squared, then plus 2ax, then plus b, just b. So on that note, we can just substitute by this in the place of f prime. We can just put 0, because we know that the derivative here at the turning point is equal to 0. So if we are deriving, then the derivative is going to be equal to 0. So here we can just put 0. Then we have negative 6x squared, then in the place of x, we can just put 5, then times 5, then 5 squared, then plus 2 times a times 5, then plus b. So we are having this one first. Then we can simplify this one to have 25 times 6, which is gonna be 150, which is equal to 10a plus b. So this is what we have. Then moving to the next one, we can also use this other turning point to say, in our derivative we can still put 0, then therefore substitute by another values, which is in the place of x we put 2. So we'll be having negative 6 times 2, then squared, then plus 2 times 2 times a times 2, then plus b. Then in the place of, okay, then now we have 4 times 6, which is 24, and then we have 24 is equal to, then just 4, we have 4a plus b, because we are adding these things up. Now this is what we have. So we can just by using the simultaneous equation, we say we are having our b, which is the same as 24 minus 4a. If I'm using this one, then the place of b here, I can just put that. Then we have 150, which is equal to 10a, then plus b. Our b is 24 minus 4a. Then therefore in the place of, okay, so we are having 150 minus 24 is going to be 126, then our 10a minus 4a is 6a. Then our a is gonna be, we divide by 6, we get 21 for a. Then we go to b. Then in the place of b, we put this 21. In the place of a, we have 24 minus 4 times 1. Then our b, it becomes negative 60. Yes, so that is what we have for now. Moving forward, because we don't have c so far, we just have b and c. So on that note, we can just go back to our function and substitute what we have. So we have negative 2x cubed plus 21, because we've solved that a is 21, then plus 21 x squared, then minus 60 x plus c. So we are having this function now, and what we can do now, we are going to substitute using one of the coordinates up. We either take the coordinates of s, which are these ones, or we take the coordinates of t, which are these ones, so to find the value of c. So let's just do it together, and let's take the coordinates of s. Coordinates of s in the place of f, we put 18. In the place of f, we put 18 is equal to, in the place of x, we will put 5. Then we have negative 2 times 5 cubed, then plus 21, then times 5 squared, minus 60 times 5, then plus c. Then solving ngoku, then we have 18 plus 2 times 5 cubed, then minus 21 times 5 squared, then minus 6 times 5. It's gonna be plus there, then the answer is just gonna be 18 plus this, then minus 25 squared, then minus 6 times 5. Then the answer becomes, in the place of, the answer becomes plus c. No, it's not plus this is plus 6 plus 60, so times 5. Yes, then plus c. Then we have times 60 times 5. Then the answer for c is 43. So we did solve that, and it was not easy. And for 7 marks, I think there is a way of doing it which is shorter than this one, but I'm not sure. This is how it is. So the idea is to know how do we use these turning points, because we just have to derive our equation, then its derivative silinganisa no 0, because we know that at the turning point the derivative is equal to 0. That is why we have now used ex values prior, knowing that f prime is equal to 0. So that is why we managed to get rid of one variable, which is c, knowing that we are going to solve it later. So this is just what we have, and I'm sorry for untidy work, but I believe you did follow what we were explaining. Moving to the next question, I would like to just wrap everything here. Otherwise, you can always come back when you have missed something. Coming to this other question, what are we having? Sorry. So we are having now, determine the equation of the tangent to the graph of f at x is equal to 1. Now, remember the equation of the tangent. What do you know about the tangent? The tangent touches the graph at a specific point. And which point is that? use this x and replace it to in the place of what? In the place of x, so that you find the corresponding y value. Then you are going to find the coordinates. The coordinates that you will find when you take this x is equal to 1 and place it to the x value there, you will get y. Then that point is called point of contact. It's the point where the tangent and the function intersect, which means those two graphs, they are equal at that point. So that is why we call it point of contact. So when x is equal to 1, what is the value of y? You really need to know that point. So let's use this equation. F of 1 is equal to negative 2, then 1 cubed. Then we remember that our formula was x a is 21, then plus 21, then times 1 squared, of course, then minus 60 times 1, then plus 43. So pressing our calculators, we know that we have negative 2 plus 21, then minus 60, then plus 43 is equal to 2. So this point of contact, its point of contact PC is equal to 1:2. So this graph or this tangent that you are looking for is touching this curve at this point. This is the point of contact. So we needed that point. Now let's continue now. In a tangent, we know that the tangent is just a straight line, which is defined as mx plus c. So we really need to know the gradient now of this tangent. Now, how do we determine the gradient of the tangent when you don't even have 2 points in a graph? Now, the idea is that we know that our function is here and we can find the gradient or the derivative of this function. What we know about the tangent and the graph is that at the point of contact or at the point of intersection, the gradients of both graphs are equal. So this is how we are going to find now the gradient of the tangent, because we are going to equate these the gradient of the function at x is equal to 1 is equal to the gradient of the tangent at the very same point. Now we are going to look for the gradient of the function, and to find the gradient of the function is to derive the function, find the derivative of the function. So the derivative after f at x is equal to negative 2x cubed plus 21x squared, then minus 60x plus 43. Then the derivative, which is f prime, is the same as the gradient of this function at a specific point. Then it's negative 6x squared, then plus 42 x, then minus 16. So this is what we have. So now the gradient at 1, because now we're looking for at 1. So now we are going to substitute now 1 quick gradient of the function to see the numerical value of its gradient, of its derivative, of course. Now what are we having? We have negative 6, then times 1 squared, then plus 42 times 1, then minus 60. Then therefore the answer that we get is gonna be the gradient of this equation of this function at 1, right? So at 1 the gradient is negative 4. The gradient of these functions is negative 4. So now we know that we are having y is equal to the very same gradient now, because at this point the gradients are equal. So we have negative 24x plus c. How do you then get this c? Remember the point that you have found, which is the point of contact. You are going to use it now to find the gradient, the value c. So in the place of y you put 2, then in the place of x you put just 1. Then we have that, then plus c, then therefore your c becomes, we have 24 plus 2, which is just 26. So y is equal to negative 24, then plus 26. So this is the equation of the tangent. For 5 marks, it makes sense. You first find the point of contact by taking this x value and substitute to your equation to find the point where these two functions are intersecting. Then after that, you calculate the gradient of which is the derivative of the function, knowing that this derivative of a function, you are going to use it with the gradient of what, of the tangent, because you know that the gradients are equal at the point of intersection. Like for example, if you have this tangent and this is the point of contact, at this point the gradients of these two functions are equal to each other. So this is just it. Moving to the next one, which is the last question in this question. It says determine x value at which at which the graph of f has the point of inflection, which means we are looking for the point of inflection, right? The point of inflection of this graph. You will remember that when you are having this function, f at x, which is f of x is equal to negative 2x cubed, then plus 21 x squared, plus then minus 60x plus 43. Now the equation of what the point of inflection is found by finding the second derivative, and the second derivative is obtained, and we came up with the formula which says x is equal to minus b over 3a. So this formula, knowing that this is your A, this is your B, this is your C, this is your D. So this formula helps you to find the x coordinate of the point of inflection. It has been derived from this formula, which is ax cubed plus bx squared plus cx plus d. So they have come up to this formula. Otherwise, you can always find the point of inflation using your x coordinate of the turning point, just to find the point of intersection, the midpoint of your turning points, to say 2 plus 5 divided by 2. You can always get this point of inflection is equal to the x coordinate of the point of inflection. Or you may use this one. For example, this one is 7 over 2, which is 7 over 2. Then also this one, now what are we having? If you are using this formula, then your b is 21, so you are having negative 21 divided by 3 times a. Your a is this one, which is negative 2, and then I believe that is going to give you the very same value, which is which is 7 over 2. Yes, so this is another way of calculating the point of inflection. Or you can derive your function twice, then your second derivative will answer 0 to find the x coordinate of the point of inflection. Now we are done with this one. For now, I would like to put a pause. We're gonna see each other on the next video. Stay tuned and please follow me. Wherever I go, I will always make sure that I do what you want to see. Thank you guys. See you right in the next video. And please guys, I really appreciate your support, what you are doing, keeping tune and making sure that you subscribe, and make sure that you are part of this family. I will always post what you really want to see, and you can also request some chapters and some questions for me to do on the comment section. I will just keep me posted so that I know that I'm with people. Thank you guys. See you right in the next video.